Good evening, great scientists, junior doctors, engineers, architects, sophists. Now, this evening we are going to examine 2024 West African Senior Secondary Certificate Examination Physics Track question number 1, mechanics. This is the diagram of the experiment. This is with third tank, this one. This is the spring balance. This is the beaker. This is the water in the beaker. Spring balance is graduated in 2 units. Gram on this side, Newton on this side. But it is preferable that students make use of Newton. The units are the vigors here because this is the SI unit of weight. Now, you are provided with a spring balance, return stand, beakers, water, kerosene, and standard masses. 1. Arrange the equipment as shown in the diagram above. Use the spring to determine the weight of the object of mass m is equal to 20 grams by hanging it freely in air. Read and record the value as W1. Number 3. Repeat the procedure in number 2 above for masses m is equal to 25, 30, 35 and 40 grams respectively, and determine the weight W1. Number 4. Calculate the mass m is equal to 20 grams in water contained in the first beaker. Read and record the value of the weight as W2. Repeat the procedure in number 4 above for masses m is equal to 25, 30, 35 and 40 grams respectively. Determine the weight W2. Read and record the value as W2. The value as W2 in the third column. Number 6. Remove the masses m from water, clean and dry them very well. Completely immerse masses m is equal to 20 grams in the liquid air, that is kerosene, provided, and record the new weight W3. Repeat the procedure in number 6 above with the object of masses m is equal to 25, 30, 35 and 40 grams respectively, and determine the weight W3. Read and record the value as W3 in the fourth column. Tabulate your readings. Plot a graph of the values of y is equal to W1 minus W3 on the vertical axis and x is W1 minus W2 values on the horizontal axis. Determine the slope of the graph. 13. This is 7, 8, 9, 10, 11, 12. Determine the slope of the graph. State 2 precautions taken to achieve good results. State Archimedes principle B1. B2. State principle of flotation. Now, let's start the experiment. This is our return stand. This is our spring balance. These are the 2 beakers. This one contains water. This one contains kerosene. We start by hanging the masses in air. But before that, there is something very important which you must understand. The density of air is 1.225 kg per meter cube. Density of water is 1000 kg per meter cube. Density of kerosene is 810 kg per meter cube. And we must know that the lower the density of a material or fluid, the higher the ability of that material to allow object to penetrate it, and the higher will be the weight. That is, density is inversely proportional to the penetrating power of a given object. Now, having put that one at the back of your mind, let's start the experiment. These are masses, 20 gram masses, and these are 5 gram masses. So let's start with 20 gram as pointed out in the experiment. We are going to use this hanger. This hanger we have its own mass, and the mass of the hanger is, the mass of this hanger is 0.1 Newton. So for all the values we are going to get, we will add 0.1 Newton to it. This is 20 gram. This is 20 gram. We hang it in air. The value here is 0.3 with the addition of the value of that hanger. So this one is 0.3 for 20 gram. We remove it and add 5 gram to it. Then you hang it in air. This is 0.35. The third one is 30 gram. So we are going to add 5 gram to this, and this one will give us 0.40. Remove it and add one more to it. This is another 5 gram plus 30. It gives us 0.45. Then you remove it gently. We have 20 gram here. This is another 20 gram. So you can remove those 5 gram out of the hanger. So this is 20 gram plus hanger, that is 30 gram, plus another 20 gram. It gave us 0.5 gram. We remove it. Now, after that, we are going to immerse the standard masses in water one by one, starting from 20 gram as written in number 4 above. So when you do that, you get This one. You profile two loops here. You hold the first one below with your left hand, the top one with your right hand, and you lower the marks into water inside the beaker. This one gives us 0.23. 0.23. You do the same thing the way you put it in. Then you add 5 grams to it. 5 grams. You add it to it. You hang it. You use both hands. Right hand to hold it on the top, and left hand to lower the standard masses into water inside the beaker. This one gives us 0.26. Then you gently remove it from the beaker. You add another 5 grams to it, make it 30 grams. Then you lower it gently into the water inside the beaker. We return it back. You lower it gently. This one will give us 0.30 Newton. Then you add 5 grams to it. Lower it gently into the beaker and hang it on the spring balance. This one gives us 0.33. Then you remove it. Bring it out gently and remove it. Remove all the 5 grams and put 20 grams together with the first 20 grams there. This is 20 grams, this is another 20 grams. So you hang it on the spring balance gently. This one will now give us 0.37. Now after that, we bring out the 40 gram mass and clean everything. After that, we now find out the weight of kerosene. The weight of standard masses inside the kerosene. We start with 20 gram. This is 20 gram. We lower it gently with both hands. You can replace the first thread because that one is wet. Take another one. Drop it gently into the liquid kerosene. This one gives us 0.25. Bring it out gently. And clean it if possible, so that now add 5 grams to it. Lower it gently into kerosene. This one gives us 0.28. Then bring it out gently. And add another 5 grams to it. Lower it gently into the kerosene. This one gives us 0.32. Bring it out. Add another 5 grams to it. hang it, use the two hands, one on top, the second one below, to lower it into the kerosene. Then you examine the value in the spring balance. This is 0.35. Bring it out with two hands. Then remove 5 gram mass, 3 5 gram mass, and replace it with 120 gram together with the first 20 gram there. This one will now give us 40 gram. Hang it with both hands. First of all, place it on the table. Right hand on the top, left hand below. Use both of them to hold your standard masses. To hold your rope. When the masses want to touch the beaker, you reduce what you used to pad it below. So this one will now give us 0.38. Now, having done that, remove everything. Clean the kerosene and place it somewhere else. Clean everything. You can place it somewhere here so that it will not disturb you. Now start the calculation. X column is W1 minus W2. And the first W1 here is 0.3 minus 0.25, which is 0.005. No, y. Okay, y, sorry. Y. W1 minus W3 is y 0.050. W1 minus W3 0.35, 0.35 minus 0.28 is equal to 0.070. 0.40 minus 0.32, 0.080, 0.45 minus 0.35, 0.100, 0.50 minus 0.38, 0.0120. Now, X W1 minus W2. 0.30 minus 0.23. That's 0.070. The next one, 0.35 minus 0.26 is equal to 0.09. The next one is 0.4 minus 0.3, 0.100. The next one is 0.45 minus 0.33, 0.120. The next one is 0.5 minus 0.37, that's 0.130. Now, having done that, I want you to observe something here which is very important. When you are writing the values here, make it uniform from beginning to the end. This is 2 decimal places, this is 2 decimal places, this is 2 decimal places. Then you observe that W1 is greater than W2 and W3 is also greater than W2. The reason being that, as I told you earlier on, density of air is the lowest, so it will allow the object, standard mass, to penetrate deeper, while the density of kerosene is the next, 810 kilogram per meter cube, so it will follow that. Density of water is greater, 1000 kilogram per meter cube, in SI unit, so that one will not allow the object to penetrate as it lies. Now, you can now plot the graph. They are directed to plot the graph of y on the vertical axis and x on the horizontal axis. So this is y-axis. The unit of y is Newton, but it's not necessary. If you like, you put it. If you don't put it, nobody will penalize you for that, since it has been written on the table. But if it is not written on the table, it is important you write it on the graph board. So we are going to make use of, we are going to start from 0, 0.02, 0.02, 0.04, 0.06, 0.08, 0.10, 0.12, 1.14, 0.16, 0.18, 0.20 on the vertical axis. The same thing on the horizontal axis. we have the lowest value to be 0.07 and the highest value is 0.13. We use 0.02 to represent 10 small square, 0.02, 0.04, 0.06, 0.08, 0.10, 0.12, 0.14, 0.16, 0.18, and the last one is 0.20. Now, when y is equal to 0.05, this is 0.05 will be between 0.04 and 0.06. 1, 2, 3, 4, 5. You count 5 small square. That will be 0.05 on the y-axis. On the x-axis is 0.07. 0.07 will be between 0.06 and 0.08. That is 5 small square. 1, 2, 3, 4, 5. You produce it upward. 1, 2, 3, 4, 5. Then you draw your point. Draw your point. 1, 2, 3, 4, 5. .05 against 0.07, then 0.07 against 0.09. 0.07 will be 1, 2, 3, 4, 5. Then 0.09 will be in between 0.08 and 0.0. This one is here. Sorry. 0.07 against 0.09. 1, 2, 3, 4, 5. You trace it up until when you get to 0.7. 1, 2, 3, 4, 5. So it will be here. 1, 2, 3, 4, 5. Then the next value is 0.08 on the y-axis against 0.1. 0.08 against 0.1. That one will be here. The next one is 0.1 against on the y-axis against 0.12 on the horizontal axis. 0.1 against 0.12. This is 0.1. This is 0.12. The last one is 0.12 against 0.13. This is 0.12 on the vertical axis. This is 0.13 on the horizontal axis. 1, 2, 3, 4, 5. Trace it up until when you get to 0.12. 1, 2, 3, 4, 5. So you can now make use of a black pen to make it a little bit clear, so that it will be easy to read. 1, 2, 3, 4. That is the last one. This 7. Okay, this is the last one. Now, you want to calculate the slope. Before you calculate the slope, you draw a very large right angle triangle, making use of your ruler, your long ruler. You join the points together. You want to cut it. So it is able to cut 2, and the remaining 3 are evenly distributed. So that is the hypotenuse side. You can now draw the vertical and horizontal side. That is the vertical side you are going to use. This is the horizontal side you are going to use. This is a right angle triangle here. A very big right angle triangle. Now, we now want to calculate the slope. This will be our y2. This will be our y1. This will be our x2. This will be our x1. When you trace the graph, y2 end here, 1, 2, 3, 4, 5. This is 0.13. y2 is 0.13. y1 is 0.02. 0.02. x2 is 0.14. x1 is 0.2123. 0. Is it 3? No. It's in between 2 and 3. You can select any one of the two. 0.02. So this one gives us 0.11 divided by 0.12, which is when you divide them together, you get 0.11 divided by 0.12 is equal to 0.11 divided by 0.12 is equal to 0.92. 0.92. That is our slope. Then the next thing after that is precautions. There are two precautions we are supposed to take here. The first one, I noted and corrected 0 error on the spring balance. When you state your precaution, you must mention the instrument. If you don't mention the instrument, it is 0. Then the second one is avoided parallax error on the spring balance, because when you are working on it, you must look at the value directly. The value you got, you read it directly. You don't read it from top or below. That's how to avoid parallax error. Then B1, you are directed to state Archimedes' principle. Archimedes' principle states that when an object is totally or partially immersed in a fluid is the combination of liquid and gas, it experiences an upthrust that is equal to the weight of the fluid displaced. B2, you are directed to state principle of flotation. The principle of flotation states that an object will float in a fluid, that is, it may be liquid alone or gas alone, or combination of the two, when the upthrust exerted upon it by the fluid in which it floats is equal to the weight of the object. Thank you very much.